This is Miss Plant's video where I'm going to try to explain Newton's laws for AQA Combined Science and Physics GCSE in 5 minutes. So we start with Newton's first law here. So Newton's first law states that an object will remain in a constant state of motion unless a resultant force acts on it. Constant state means it will keep doing what it's doing. Constant state could be 0 meters per second, it could be 1,000,000 meters per second. Just that it remains constant is important, and the idea that a resultant force acts on it means that yes, there are going to be forces acting on it, but there needs to be a resultant force. Those forces need to be unbalanced, and if they're unbalanced, there is a resultant force. This idea is very closely linked with the idea of inertia that you need to understand. Inertia is the tendency of objects to continue in their state of motion, as in things tend to do what they're doing unless a resultant force acts on them. That will change their motion. But inertia states that things tend to do what they keep doing. Now, from a free body force diagram, you might have a diagram like this, 40 newtons acting left, 40 newtons acting to the right. This has a resultant force of 0, which means it is in a constant state of motion. Now, the instant thing that you might want to say, and what the exam board often like to trick you with, is you think, okay, 0 newtons, 0 velocity. It's stationary, 0 meters per second. That could be true, but that is not always the case. And you need to understand that a constant state of motion does not necessarily mean stationary. This car, for example, 4,000 newtons of thrust is equally balanced out by 4,000 newtons of air resistance. This car is not stationary. This car is moving at 30 meters per second, which is about 70 miles an hour on the motorway. So even though the resultant force on this car is 0, it still has a velocity of 30 meters per second, and all that the resultant force being 0 tells us is that it will continue in its state of motion. Its state of motion will not change. Now, Newton's second law helps us if we have a resultant force acting on the object. Newton's second law tells us what's going to happen. So this is an example of a resultant force. This is a free body force diagram. We've got 50 newtons acting to the right, 20 newtons acting to the left. Force is a vector, so I've said plus 50 to the right, minus 20 to the left to represent the fact that it's a vector, so it has magnitude and direction, meaning my resultant force is 30 newtons to the right. This means that object will accelerate, and acceleration means it could do 3 things. It could speed up, it could slow down, or it could change direction, because acceleration is change in velocity. Velocity is a vector, so changing direction means you are changing your velocity. You most commonly see that when talking about orbits, because orbiting as the Earth orbits the Sun, it is accelerating because it is changing its velocity. Now, so Newton's second law says, well, there is a resultant force acting on this object, so it will accelerate, and the force is equal to the mass times the acceleration of the object. Force is measured in newtons, mass is measured in kilograms, acceleration is meters per second squared. You need to memorize that equation. I like to remember it by going FMA to myself, FMA, but you need to memorize that equation. Force is mass times acceleration. It always comes up. Force, and this equation can tell us two things. First thing it can tell us is force is proportional to acceleration, as in if you double force, you double the mass. The second thing it could tell us is that acceleration is inversely proportional to mass. We can rearrange this equation 2 ways. So if I write the equation out, divide by mass, those masses cancel, we get acceleration is force over mass. If I write it out again, divide by both sides by acceleration, they cancel on this side instead, and I get mass is force divided by acceleration. And force divided by acceleration is a special value. It's called the inertial mass, and the inertial mass is a measure of how difficult it is to get the object to move. Right? You need to know that. Now, Newton's third law is a more general law about forces in general, and when two objects interact with each other, they exert an equal and opposite force on each other. All forces come in pairs thanks to Newton's third law. Every time there's a force, there always is an equal and opposite force. The force pairs act on different objects though, so don't be fooled, you can't draw a free body force diagram for them because they are acting on different objects. An example would be if these two cars were to collide, the force of car A on car B is equal and opposite to the force of car B on car A. Equal and opposite forces. Newton's third law explains how birds can fly. The bird flaps the wings down, that pushes the air down. the force of the bird on the air acting down. The opposite force is the force of the air on the bird, which acts up. A submarine propels itself using a propeller. The propeller pushes the water back. The force on the submarine from the submarine on the water goes backwards. The equal and opposite force of the water on the submarine pushes it forwards. That is Newton's three laws.